Cool. Sounds right. Thanks for the introduction. Yeah, excited to be here. One thing I talked about a little bit with Rihan is if you have any questions, feel free to just ask them as we go. So you can, turn on your mic and ask me, or you can drop in the chat and I can monitor that. I go kind of quite fast and cover a lot of stuff, so please don't hesitate to ask any questions if you have them. But with that, let's get started here. And part of what I'm going to be talking about today is serverless. And let's start off with a little bit about serverless, this whole ecosystem, what it is. I think this whole serverless paradigm got started in 2014 when Werner went on stage at reInvent, introduced AWS Lambda, right, where you have this serverless compute infrastructure where you just upload your code to Lambda and it's going to run that code in this isolated container for you and do the work you want it to do. And the important part about that is that code is triggered by something, right? It's event-driven compute. So something happens and you trigger it. So that might be an HTTP endpoint. So you use something like Amazon's API gateway to trigger an HTTP endpoint, call that Lambda function and handle that HTTP request for you. But often, API gateway and Lambda is not enough on their own. You need some other sort of backend service that Lambda is using as well. Maybe something like S3, if you're storing or retrieving blobs of data, or maybe something like SQS if you want to be in queuing messages to queue up some later work asynchronously later on. It could also be a bunch of event-driven stuff. Amazon Event Bridge, Kinesis for stream processing, SNS for sort of pub/sub-like stuff. So you can be using all these different services, but at the end of the day, you're probably going to need some sort of database, right? And you have a lot of options there as well. You can use Amazon RDS, which is a managed relational database service for MySQL, Postgres, things like that. You can use DocumentDB, which is basically a MongoDB compatible database. Or you can use DynamoDB, which is what I'm going to be talking about here today. So this is about using DynamoDB in serverless applications. And I want to cover three main things here. First, we're going to talk about why DynamoDB and serverless, because I think Dynamo has been the most popular database in serverless applications. And I want to talk about why, sort of apart from all the data modeling stuff, which is what we'll get to later on in the talk, but sort of what are the non-data model reasons why a lot of folks are choosing Dynamo in their serverless applications. Once we have that sort of why, then we'll go look into data modeling itself. So we'll talk about the basics of data modeling with DynamoDB, get the foundation under you there, and then we'll go into one-to-many relationships, which I think is just a good way to sort of hammer some of that stuff home. Get a little more into that intermediate expert level, but understand what this is about with Dynamo. So. Who am I? I'm Alex DeBrie. I wrote the DynamoDB book, which is just a guide to data modeling with DynamoDB. Also created DynamoDBguide.com. So I'm definitely in the Dynamo space, big fan there. And I'm an AWS Data Hero and just a general, AWS and serverless fan. I mentioned the book, DynamoDB Book. You can go check it out at DynamoDBBook.com. I think we're going to give away a copy here at the end as well. It's just a comprehensive guide to data modeling with DynamoDB. So it walks through a bunch of different stuff, relationships, sorting, filtering, uniqueness, all this stuff. And also has 5 walkthrough examples, some pretty in-depth ones. So check that out if you're interested. But yeah, let's get started here with why DynamoDB and serverless. Why are so many people choosing to use DynamoDB in their serverless applications? And I think there are 5 big reasons that this is happening. So first one is just the interaction mechanics of using Dynamo in your serverless applications. So if you're working with Lambda functions, you're probably using other AWS services like I mentioned, and you might be using something like SQS, right? You need to enqueue a message. And if you're using SQS in your service, it's probably going to look something like this, where you import Boto 3. This is Python, so that's the AWS SDK for Python is Boto 3. So you import the library, you create a client, and then using that client, you call the method on that client, which is going to correspond to the method for that service. So here we're creating an SQS client and sending that message. Likewise, if you're using S3 in your application, it's going to be pretty similar, right? You'll import your library, you'll create your client, and you'll call your method on it. Well, if you're using DynamoDB, it's the exact same mechanics that you're going to be using there, right? You're going to import your library, you're going to create your client, and you're going to call your method. And it's going to be very similar to using any other AWS service in your Lambda function. And this is going to be in contrast, if you're using a relational database, you got to get that sort of library in there, make sure it's compiled for the right for that Lambda system, and then, maybe have a long-running shared client somewhere and different things. So the mechanics are just more in line with Dynamo as they are with other AWS managed services in your serverless application. So that's the first one, pretty simple one. The second one sort of ties in with that, and it's the permissions model around how Dynamo works. How do you manage access to your Dynamo table. So, if you're working with AWS and services, things like that, you're probably familiar with IAM, which allow you to access different things, right? And so here's a little bit of code I have, which is giving permissions to my Lambda function. You can see at the top there, if I'm using SQS, I'm going to set up an IAM role statement that says, hey, allow this particular action for this particular resource. And that's what it looks like for SQS. And the great thing here is it looks the exact same for DynamoDB. You're doing effect action resource, same exact thing. Again, contrast that with other databases, a relational database. You got to log into that database, create a user, assign permissions within that database, which is a system outside of IAM altogether. So another thing that's great about the permissions model and how it works with serverless and Lambda functions is your Lambda function is going to get temporary credentials injected into it. And those credentials, they're going to be scoped to exactly what you have given them, but they're also going to expire after a certain amount of time. And you don't have to worry about sort of credential management and rotation like you would with a database username, password, things like that. Also, these credentials are just automatically discovered by the AWS SDK if you're using that in your Lambda function. So it's very easy. You really just don't need to think about sort of credentials. You just need to worry about those IAM statements that you set up. So that's the second one. Third one, again, is similar to that, the provisioning model. How do you provision a DynamoDB table as compared to other databases? If you're looking at the provisioning model, you're probably using some sort of infrastructure as code with your serverless application. So you might have something like this where you're setting up an SQS queue, right? If you're doing some other AWS service, it looks like this. If you're setting up a DynamoDB table, it looks the exact same. So you're getting familiar with that infrastructure as code and what it looks like to set up those resources. The great thing here about Dynamo compared to a relational database is you can really set up everything you want with Dynamo in your infrastructure as code in that provisioning model. So you can set up your table, you can set up your indexes and permissions and all that stuff. Whereas if you're working with that relational database, maybe you can spin up that relational database and maybe the networking stuff and all that for it. But you still need to have some other process that goes in and creates the tables, creates the indexes, creates the users, creates the permissions, all that sort of thing, which doesn't quite fit with that infrastructure as code paradigm. So what we're seeing, infrastructure as code, very popular in the serverless world. It's something that predates serverless, but I think you've really seen serverless folks pick it up because of how much the infrastructure becomes a part of your application in these serverless applications, right? Your infrastructure is not as slow moving as it might be in sort of a pre-serverless world where maybe you set up your VPC once, you set up a auto scaling group of EC2 instances, but really it's your code that on those instances that's changing. Whereas in a serverless world, you're creating queues, you're creating tables, you're creating S3 buckets, all that stuff, and it's really a part of your application that's deployed with your function code all the time. Two big players there going to be CloudFormation and Terraform. I would say if you're in that serverless world, CloudFormation has sort of been the big one. I think most of the major tools use CloudFormation, even though Terraform might be more popular in sort of other areas. As Ariana notes here, CDK also very popular. CDK compiles down to CloudFormation. So I say CloudFormation, but really I'm saying anything that sort of is built on top of CloudFormation, which could be CDK, it could also be SAM, it could be serverless, it could be arc.codes, a lot of things that really compile down to CloudFormation and use that. And the big part there with infrastructure as code is that it's repeatable, right? You have this all set out as code. You can deploy a new stage of it. You can deploy it in a different account, all that stuff very easily. So those are the first three. The fourth one, let's go a little bit different here. Let's talk about the billing model of serverless and how it of DynamoDB and how it compares to other databases. I think there's a very interesting billing model for DynamoDB and sort of on two different levels. So first of all, you're paying for reads and writes directly rather than resources. So first, let's think about what we do with a relational database or even Mongo, right? You're usually saying, spin up some instances with this much CPU, this much RAM, this much IOPS, this much networking, things like that. And what you're doing is maybe doing some traffic planning or capacity planning on how much you need or how many requests you're going to have. But then you're sort of guessing on how that turns into CPU and RAM and IOPS and all that sort of thing. With Dynamo, you're paying for what are called RCUs and WCUs. So this is read capacity units and write capacity units. And it's just more in line with what's actually happening. So a read capacity unit is reading 4 kilobytes of data from your DynamoDB table. A write capacity unit is writing 1 kilobyte of data to your DynamoDB table. So, capacity planning is going to be hard sort of no matter what, but if you can have an estimate of how many users you're going to have, how big those operations are going to be, you can translate that directly into RCUs and WCUs rather than having sort of this black box of, well, how does that translate into CPU or RAM or something like that? So it's a much more straightforward billing model, I think. The other thing that's really amazing about DynamoDB is it has these two different modes. You can use provision capacity or pay per use. So provision capacity is saying, hey, I want some RCUs, WCUs that I'm going to provision up front, and I want this much per second. So maybe I provision 1,000 RCUs and 500 WCUs, and that's how much capacity I can use per second on my table. You pay for that ahead of time, just like you would with other databases. On the flip side, there's also pay per use, where it just charges you for each read and write that you make. So you say, hey, I don't want to provision and think about this ahead of time. Just make sure you can handle my reads and writes. As those reads and writes come in, they're charging you, micro pennies for each read and write that you have, and then they'll just send you a bill at the end of the month. So that pay per use really gets into that pay per value ethos that we have in the serverless ecosystem, right? With Lambda, with API Gateway, with SQS, SNS, all those things are sort of pay per use, and DynamoDB can be too, which is pretty amazing when you think about it with a database. So the billing model fits in really well. The last thing I think that's nice about DynamoDB and serverless is sort of the scaling characteristics of how Dynamo works. So I just want to show a little chart here, and what I have on the x-axis is data size, right? How much data do you have in your database as it sort of grows, and we get 1 gig, 10 gig, 100 gigs, 1 terabyte going up. On the y-axis, then I have performance, right? And at the very bottom, it's blazing fast. You have really quick response times, then fast, sluggish, and painful, where your users are actually complaining. Now, if you're working with a relational database, something like MySQL, you might see a performance curve like this, right? Where it's very fast when you just launch your application, or maybe when you're running in test environment or locally, things like that. There's a gig of data, everything fits in memory. It's great, it's super fast. But eventually, it's going to slow down. You get 100 gigs of data, and maybe now it's getting a little bit more sluggish, and people are starting to complain about, hey, what's going on here? And you need to investigate. Maybe you need to add some more indexes or beef up your instance size or something, but you need to do that. And then you might eventually get to the point where performance is so painful, terabytes and terabytes of data, that you actually need to re-architect, right? And so you've got this sort of long-term drag on your developer productivity, where you might have to go back and investigate and re-architect as your table grows. If we contrast that with Dynamo, it's going to look much flatter. Your performance is going to be essentially flat over time, no matter how big your data grows. And one thing that's nice about this is it gives you a lot of consistency and understanding of how is this going to perform as it scales, right? It's going to perform the same on your local machine as in your test environment as when you have 10 terabytes of data, just because of how it's designed. And we'll talk a little bit about how that design works, some of the implications of that later on. But I think this is an important thing to know, right? And one thing to note there, Dynamo is not going to be faster than MySQL at the very low end. But the nice thing is it's going to be very consistent as it scales, which is a different set of properties if that's what you're into. So those are the 5 main reasons I think people are picking up Dynamo in the serverless world. And we haven't talked about the data model stuff yet. And the data modeling is very different in Dynamo as compared to a SQL relational database. And I want to walk through some of that stuff here so we get an understanding of what that looks like, because all those considerations I already talked about have nothing to do with the data model. So basics of data modeling. First of all, I want to start off with some terminology. So 4 key terms to talk about here: table, item, primary key, and attribute. We're going to look at this by way of an example. So here's an example here. I have, some users in my table, users for my application. In this one, I have 4. I have Alex, DeBrie, and a few folks from Amazon: Jeff Bezos, Jeff Barr, Werner Vogels. If you look at all that data together, that's going to be called a table, right? All my data together is a table, similar-ish to a relational table, but different in other ways as well. If you look at an individual record, that's going to be called an item. So that's going to be similar to a row in a relational database or a document in something like MongoDB. Now, each item that I put into my table needs to have a primary key. And this primary key is something that I define on my database. And that primary key is going to uniquely identify each item in my database. So you can't have 2 items with the same primary key. In this example, I have, I'm using username as that primary key. So you can see each of these users has a username that's going to uniquely identify them, which works well because I don't want to have 2 users with the same username. Primary keys are going to be very important, as we'll see sort of throughout this process. In addition to that primary key, you can have other attributes on your table. So here I have first name, last name, email. you can think of these sort of like columns in a relational database, with a big difference being you're not going to define these up front on your table like you would in a relational database. So you won't say, this table has first name, last name, email, attributes. You only define that primary key, and then other than that, DynamoDB is schemaless. So it's not going to enforce your data as it comes in. That's sort of the responsibility of your application to do so. We'll see some interesting implications of that as we go on. Another thing to note with attributes is here we have string values, you can have integer values, but you can also have complex values like lists and sets and maps and things like that, nested values, and we'll see what that looks like as we go on here. So we talked a little bit about the primary key. I want to dive into that because it's so important. And there are two types of primary key. There's what's called a simple primary key, which consists of just a partition key. And there's a composite primary key, which has two parts, a partition key and a sort key. So hold on just one sec. Again, feel free to ask any questions or tell me to go back if I'm going too fast here. But so simple primary key, we already looked at this table of our users, right? And that has simple primary key. It had just a partition key. That was the username that uniquely identified each user. You could also have a composite primary key, maybe something like this. And here what I've done is I've got those same items in my table, but I've added a partition key of employer. So each user has an employer that they belong to, and then that sort key is the username. So you can see it has two parts, right? And for me, example, I work for DeBrie LLC, and then the other folks work for Amazon Inc. The important thing to note there is it's the combination of those two elements that need to be unique. So you can see multiple items that have the same partition key. That's okay because they each have their own username, and so that sort key partition key combination is unique. One thing that's really nice about this, and we're going to get into it later on, is it's very efficient for me to find all the items that have the same partition key if I'm using that composite primary key. So it's very efficient to me to say, hey, give me all the employees that work for Amazon Inc. I can do that very quickly. And that's going to enable more complex applications than if you're just using that simple primary key with the sort of key value access patterns. So I've mentioned a little bit about how DynamoDB data modeling is different than other ones, and I think this is the reason behind it, and it's what I call DynamoDB's guiding principle, where this isn't something they state in the docs or in their marketing materials, but I think if you look at the product decisions they make and what they allow and don't allow, basically they do not want to allow operations that won't scale, right? So if we go back to this chart, they want to make sure that you have that consistently flat performance curve that's not going to be changing over time. They don't want to sort of give you as a developer the ability to shoot yourself in the foot and do something that's not going to scale over time. So they try to limit the things that won't scale intentionally. So we'll see a couple different ways they do that. Number one is the importance of primary keys. So if we go back and look at that table example we had where we have that primary key of employer and username, we also have these attributes, right, that are schemaless. The important thing to know is you can query with that primary key. It's very easy for me to say, hey, go get me Alex DeBrie within DeBrie LLC, or go get me all the employees in Amazon. I can do that very quickly because that's in my primary key. I can't sort of query off my attributes very easily. So I can't say, hey, go get me all the people whose first name is Jeff, right? And get Jeff Barr and Jeff Bezos. That wouldn't be very efficient with DynamoDB. So that's the first thing you need to know. Primary keys are very important. That's what's going to actually drive your access patterns. So you need to design them that way accordingly. The second thing to know about Dynamo is there's no join operation, right? So if you're coming from a SQL world, you're used to this join where we can join different tables together. There's no join in DynamoDB, partly because of scaling reasons. So let's look into sort of what's going on under the hood with Dynamo. And you don't need to know this necessarily. A lot of this stuff isn't exposed to you as Dynamo, but I think it helps to know these underlying principles if you want to understand how to model properly in Dynamo. So, so far we've been talking as if Dynamo is this giant supercomputer database in the cloud. But what's going on there is that front end is sort of a facade. And what you have behind the scenes are these different partitions that hold your different data. So your data is going to be partitioned across all these different nodes. So here I have partition 1 and partition 2. Each partition is going to hold a max of about 10 gigs. So maybe you have 15, 20 gigs of data here, and you have it split across those two partitions. Now, when a request comes into Dynamo, this is what's going to happen. So let's say we do a put item request. We want to put a new employer or person into that Amazon Inc. employer. We want to put Andy Jassy in here. It's going to hit that DynamoDB front end, which is called the request router. And the first thing it's going to do is hash that partition key. So it's going to take that partition key, which in this case is employer. So it's going to take Amazon Inc. It's going to hash that and then figure out which partition it belongs to. So which partition does it belong? In this case, imagine it belongs to partition 1. It's going to go put it on partition 1. Now, the great thing about this is we only have 2 partitions here, but it easily scales if you have 3 partitions or if you have 9 partitions or if you have 1,000 partitions. And the reason this scales so well is that first thing that happens is an O1 operation, right? Hashing that partition key and looking for it in a hash map to determine which partition it goes to. That's an O1 operation that's going to scale, if you have 10 gigs or if you have 100 gigs or if you have, 10 terabytes of data. The first thing you're doing is doing that O1 operation to narrow it down to 10 gigs, 1 partition, and then search within that. So it's a lot more efficient that way. So I think understanding this partitioning is really helpful, but also why they don't have join operations or why that primary key is so important, because they're sharding your data like this across all these different partitions. So those are 2 big things to know about sort of a NoSQL database like DynamoDB. What are the big implications of these 2 things that we've talked about? First of all, you're going to want to use something called secondary indexes, right? So let's go back to what we were saying, the importance of the primary key, where I can query with that primary key stuff, employer username, but I can't query with those attributes. But what if I do have access patterns for those other attributes, right? Like what if I wanted to look up a user by their email address? That's one of the attributes which doesn't have very efficient access. What I can do is set up what's called a secondary index, which is declared on my table, and it basically gives me an additional primary key for that index. It's gonna, when I write data into that table, it's going to reshape it into this secondary index as well. So now in my secondary index, this is what it's going to look like. And I have that primary key over there with a partition key of email that then I can query on that very efficiently and get someone with a particular email. So secondary indexes are going to be a huge part of DynamoDB to get around sort of that limitation of the primary key stuff. So what's going on there again? Data from your base table is copied into that secondary index with the new primary key, and Dynamo's handling all that for you. You just declare that secondary index. Whenever you write to that base table, it's going to get copied into that secondary index that you can query. The important thing with secondary indexes is you can use query or scan, which are both read operations. You can use those on that secondary index, but you can't do writes against that secondary index. So all your write-based patterns, you're going to need to use the core primary key for your base table and make sure you design your table accordingly. But then you can do read-based operations on these secondary indexes. So that's the first implication of sort of this SQL versus NoSQL stuff. Another part is you need to know your access patterns in advance. And this is where that primary key, the importance of that primary key comes into play. You need to know how you're going to sort of structure your data or access your data before you go out and structure it. And this is different than a relational database, right? Where you're going to sort of design your table in one way, this normalized fashion. And then once you've done that, then you'll say, hey, how do I access it? I need to access by username. I need to access by email, whatever. Maybe you add some indexes there. DynamoDB, you need to do it before you design your table. And then we get into the more controversial part, or the weirdest part, at least, where we, what's called single table design. Sorry, where you're putting all your items into a single table and using generic attributes for your primary key. So this is what often trips people up when they see Dynamo for the first time. Very kind of interesting to see, but let's go check out what that looks like. So I want to walk through this with an example application. This is like a SaaS application. Imagine I'm building a SaaS application and I have 2 types of entities I want to put or use in my application, right? I have organizations and I have users. And organizations sign up for my SaaS application and they buy maybe 5 seats or whatever, and then users can use those seats and be in my application. They can each log in and use it. So let's get started by modeling the organizations first. So here's my table. I've got 2 items in this table. I've got Berkshire Hathaway and Facebook. I want to call out 2 things here because we're going to be using this single table design and a couple things to note here. First, look at that primary key. In the partition key and sort key, I've given very generic names. Partition key is just PK, sort key is just SK. Now, the reason I'm doing this is because we're going to be putting different types of items into this table. We're going to be putting organizations, but also users into this table, and they're not going to have the same sort of attributes and columns, right? Organization might have org name, but user wouldn't have a username, or wouldn't have an org name, it'd have a username, and vice versa for organizations. So we're going to use these generic column names to sort of organize these items. Second thing to note here, if you look at the actual values for partition key and sort key, they're kind of unique, right? They each have this prefix of org hash and then the organization name, Berkshire, org hash, Facebook. And the reason you're doing this, again, is you're putting multiple different items into this table. You want to be able to distinguish between which type they are. You want to be able to prevent overlaps and duplicates between different types of items. And it's going to help with grouping and different things like that as well. Andre, good question. I'm going to finish up this SAS example and then I'll circle back to you. But okay, so now we've got our organization items in our table. Let's add some users in here. So now I've got that same table. I've got my 2 organization items in there, but I've also added these 3 user items. So I have Charlie Munger and Warren Buffett for Berkshire. I also have Sheryl Sandberg for Facebook. A couple of things. One thing you want to note there, look at the attributes, how those are different for the user items than the organization items, right? And that's part of that schemaless nature of Dynamo, where you don't need to have the same attributes. You don't define these attributes up front. They can be different for different types of items. Also, just look at the sort key pattern for users versus organizations. They're different, right? Users have user hash and then the username, or organization had org hash organization name. Now, one concept that's important when you're working with DynamoDB is this concept of an item collection, which refers to all items that have the same partition key. And remember, that's really important, because if we go back to, how DynamoDB works, that first thing they're doing is hashing that partition key, and it's very easy to sort of find all the items with the same partition key. So that's called an item collection. You can very easily find out where those items are all located. So here we have an item collection here. One thing I want to note here is you can actually have different types of items in the same item collection. So here in this org hash Berkshire item collection, we have that organization item up top. We also have some user items below, and we'll see in a little bit about how that can be useful when you want to sort of pre-join your data to get different types of data located near each other, which is going to scale really efficiently without having to do that SQL join operation. Last thing I want to say, just sort of the implications of SQL versus NoSQL, is you need to get comfortable with denormalization, which I think is something that can be hard for someone. If you've done a lot of relational SQL-based data modeling, you're used to normalizing your data. You need to get comfortable with relaxing that a little bit. I don't think you should go all the way to the other end and totally denormalize your data, but understand when normalization can help you and when denormalization can help you as well. So those are some basic principles. I'm going to answer some questions here. So Andre's got a question. Can we integrate DynamoDB with Cognito so some auth is managed incognito in a SaaS application? So I'm going to, there we go. Etienne just had a question or a response to this. So integrate the app with Cognito authentication, obtain tokens, and use Cognito identity pools to exchange the user pool token for temporary credentials. So basically what's going on here is you can use Cognito to actually dispense AWS access tokens to access a database directly, a DynamoDB database directly. You can actually add very scoped permissions as well, to where you say, hey, this user only has access to items that have this partition key, right? So they can't sort of get stuff outside their organization, things like that. So you can use those identity pools if you want to. Otherwise, if you want to use Cognito just as a JOT dispenser, and then in your backend sort of validate that JOT, then based on that give them access to your table, you can do that as well. But yeah, you can actually do sort of direct AWS access calls from your client using these Cognito identity pools to sort of scope down access to your table. Cool. One other question, Darius. One thing that is still fuzzy: how do you ensure you get good partition spread? For example, with org hash Berkshire, if you have, so basically, if one thing that's very important with Dynamo is, you want your partitions to be roughly equal. They don't have to be strictly equal, but you don't want to have what's called a fat partition, where all your items are in one partition and have the same partition key. So you want to spread your data across the table. So what if you had an organization that had way more users than any other one? I have some good news for you, and that's that Dynamo has done a lot of work in the last couple of years to reduce how big a problem this is. So they have it used to be sort of all the capacity you'd provision for your table was equally split across all your different partitions. So if you had 4 partitions and you had 100 read units provisioned, each one of them would get 25 units, which meant if you had sort of an unbalanced query pattern where one partition was taking a lot of those reads, you'd have to over provision to make sure it had enough. DynamoDB's done a lot of great work with what they call adaptive capacity now, where instead of sort of allocating that capacity evenly across your partitions, they'll sort of move it around to whatever happens and need it at the time. So you don't need to think about it in that sense nearly as much as you used to. The one big thing you do still need to think about is just overall partition throughput limits. So an individual partition that you have is only going to be able to handle a maximum of 3,000 read capacity units or 1,000 write capacity units per second, and that's on any given partition, which is a pretty high scale, right? 3,000 read units per second means you can read 12,000 kilobytes of data per second within just that partition, right? And you can have all these other partitions that have their own stuff. So these are pretty high limits. If you have a high scale application, you might run into some issues with those, and then maybe you need to add DAX in front, which is like sort of a caching layer. You can do something like that, or do other sort of strategies to handle that. But I would say the work that Dynamo has done with adaptive capacity has really reduced some of these imbalanced partition issues, which is really nice. So make sure you're going to hit those throughput limits before you really start to worry about that. Good question. And then Zaid has a question, implications of reserving read and write capacity versus on-demand. So using that provision capacity versus on-demand capacity. Is there a performance impact of that? No, there's not a performance impact. You're going to see the same performance on provision throughput as you would on on-demand, with some tiny caveats to that. If your on-demand scales up to a level it's never been and like significantly beyond that really quickly, there could be a brief period where it needs to scale up and you'll get throttled. But then once you hit that new level, it needs to scale up another 10 times that again before it gets throttled again. So only in very extreme scaling circumstances will you have some throttling issues with that on-demand mode, but otherwise performance is the same. The big difference between on-demand and provisioned throughput is on a fully utilized basis, on-demand capacity is going to cost about 7 times as much as provisioned capacity. The problem I would say is it's actually pretty hard to get fully utilized database capacity, right? Go look at your EC2 instances or your databases right now and see how well they're doing in terms of CPU and RAM and all that stuff. It's pretty hard to get that correct, not just sort of at any given time, but also as usage fluctuates during the day, during the week, during the month, things like that. So, if you're not getting good utilization out of your table, think about using on demand to just, you might save money or at least break even there. And it's just a lot less capacity planning you need to do. Also, you're talking about having a new app that you're setting to on-demand mode. I think that's a great way to get started. You can run that for a while, see sort of what your traffic patterns are, and then you say, hey, what if we just set our RCUs and WCUs to 100, and do something like that. And you say, okay, that saved us a little bit of money. We know our traffic patterns now, and that can work for us. So you can do something like that. So you can switch your table back and forth from on-demand to provisioned as well. Andre, question, is that I/O limits on DynamoDB compared to I/O on SSD drives? I'm not really sure sort of what's driving that. I would say that's like, think of Dynamo as a managed service and don't get like deep in the weeds on what's happening there. But just know that you have these hard limits on a particular partition. 3,000 RCUs, 1,000 WCUs per second is the best way to think about it. Darius, bursty traffic on demand can be cheaper. Absolutely. I think it's really hard to get good utilization out of your table. Thanks for clarifying. Cool. I think that's all the questions. I'm gonna keep on rolling, but again, keep these questions coming, and I'll stick around for a while at the end as we want us to. And Rihan said they're giving a copy of the book. So cool. We've done some basics with DynamoDB, learned a little bit of terminology, learned a little bit of like sort of the decisions they make and the implication. I think to bring it home, it's useful to look at one-to-many relationships and how you model that in DynamoDB in some different ways, right? I talked about denormalization. Well, I'm going to show you a few ways this happens. So let's talk about one-to-many relationships in DynamoDB. Just as a quick refresher, like what is a one-to-many relationship? It's whenever you have some sort of parent item that has multiple child items. So you might have, a particular office building has multiple employees that work in it, or you might have a customer that on Amazon.com or wherever you're shopping makes multiple orders, right? I make multiple orders, or you hope I do as I keep coming back. Or in the example we already showed, that SaaS app, right? An organization has multiple users that belong to its plan and can operate on behalf of that organization. So when we're talking with one-to-many relationships, there are a lot of different strategies on how to model that with DynamoDB. I have 5 of them outlined here that we'll walk through. And the big thing here is it's different than a relational database where there's generally like one way to do things. You set up that foreign key relationship and then you join across it. We don't have joins in Dynamo, so we have these different strategies that depend on the specifics of your situation. You see what your situation is and which one you should use here. So first strategy is what I call denormalization using a complex attribute. So let's go back to that example we already had, this SaaS application, right? We've got an organization, we've got some users. Because this organization has subscribed to our plan, they have to set up some sort of like payment method, right, of how they're going to pay for this. And maybe we allow them to pay or set up multiple payment methods, right? They can have their credit card, but if that fails for whatever reason, they can fall back to like a bank account or something. Now, if we think about that, how that payment method works, we're not going to have any access patterns specifically on that payment method, right? You're never going to say, hey, I have this credit card number. Who does it happen to belong to? Really, the only access patterns you're going to have is maybe on the settings page for an organization, they want to say, hey, what are all my different payment methods? And you list them, so you're within the context of that organization. Or, it's the end of the month and you're billing everyone. You go through and say, okay, pull Berkshire's account. I want to charge them, things like that. So it's always within the context of that organization. So given that, we're going to use what's called a complex attribute, and this can be kind of small maybe, but I just want to highlight what we've added here. We've added this attribute called payment method onto our organization items, and it's using a complex attribute. It's using a map, which is saying, hey, here's your default payment method, here's your backup one, or different things like that. And it takes in a credit card number, all that stuff. So it's a complex thing. And rather than sort of separating it out in a different table that we join across, we can't do a join here. We're just going to denormalize it and put it onto that organization item itself. So that first strategy is denormalization with a complex attribute. This is good when, number one, you don't have an access on that related item directly, because you can't do a secondary index on a complex attribute like this. But here we're not saying, hey, here's this bank account number, here's this credit card, who does it belong to? We never have that. We're always doing it within the context of that organization, which we know how to find. So then we don't need to sort of index that in a separate way. It's also good when you have a limited number of related items, because each item in DynamoDB is limited to 400 kilobytes. So one of our examples before was customers and orders. You wouldn't want to do this with that sort of pattern with customers and orders, because maybe I keep coming back and making orders and you're jamming it into this complex attribute. And at some point I make enough orders where your item's too big and now you can't do it. And you say, well, like you don't want to sort of block someone from making an order because you have a bad data model design, right? That'd be a bad strategy. So if you have this limited number of related items where you're saying, hey, I'll let people save 2 or 3 or 4 payment methods, that's fine to denormalize it, put it onto put it into a complex attribute here, but not if it's going to be sort of unbounded. So second example here is another denormalization example, and this is denormalization plus duplication, which is kind of a no-no in relational and in normalized data modeling. But let's look at what we have here. Imagine I have like a bookstore or a library, something like that, and I have books by different authors, right? And I have a composite primary key where the partition key is author name and the sort key is book name. When you're fetching that individual book, you might want to get information about the author with it. So what I'm going to do on this one is just duplicate some of that information from the parent item, from that author, onto that book. So you can see here I have 2 books by Stephen King. On each of them, I've put that author birth date there. So then when I go fetch It or The Shining or whatever it is by Stephen King, it's going to come back with information about that author. So I don't have to go make a second request to follow up and get information about the author as well. So we're denormalizing here by duplicating data, right? Which you wouldn't do in a normalized data model. So when is this strategy a good one? When two things are, one of two things are true. First of all, if that duplicated data is immutable, right? Stephen King's birthday is not going to change. It's not going to be some different day in a few months or in a few years, things like that. So it's okay for me to copy it onto that item and not have to worry about it changing and becoming stale or incorrect. Even if that data is not immutable, maybe it doesn't change very often, or it's not replicated across that many items, this can still work for you, right? So if you have some data that changes, maybe once a week or once a year or something like that, and it's only shared across 3 different items, that might be worth it to sort of duplicate it, make that read cost a lot cheaper, and then the 3 times a year when you need to update it, and update it across 3 items, it's not that hard to go find those items and update each of them and keep your data integrity there. So in that situation, you need to balance, like how much work is this going to be to keep it in sync versus, what's the reduced reads if I have it duplicated. So the first two strategies were both denormalization strategies. The second ones are sort of more specific to DynamoDB. This one's composite primary key plus a query, right? And this is one we already sort of took a look at, but imagine you had an access pattern where someone wanted to fetch all the users for an organization. As part of that, there's information on the organization item itself that you want to sort of enrich onto each user to give them some information about it. What you could do is sort of organize them in the same item collection. So what we've done here is we have this item collection that contains both an organization item and the user items below it. So what I want to do is if I want to fetch all these users and enrich them with some organization data, this is one query to go to DynamoDB. It's going to be very efficient to get all those items together. Then I have my organization item. I can enrich those user items with that information. They're all co-located. This is going to scale really well without having a join. So what I'm doing here is basically pre-joining my data to handle this access pattern. So this is a very common one if you're doing sort of that list-based thing where you want to sort of pre-join the parent item with its child items. The next strategy I call secondary index plus query. This is going to be very similar to the last one with a caveat here. So far we know we've talked about organizations and users, but what if we added a third entity type in the mix, maybe something like tickets, right? So if you had like a Zendesk application where you get assigned tickets to a different user, and you have another sort of one-to-many relationship pattern there, right? A user has many tickets. And you might think, hey, I'll just sort of jam those users in, or jam those tickets in between my users. So I'll use that same sort of thing, put them in the same item collection. I can gather that really quickly. You can see right there, Charlie Munger and his tickets are really close to each other. And I've got this in the same item collection. I've got the user item plus the ticket items. The problem here is if we go back to our last access pattern, right, we wanted to have our organization and user items really close to each other. But now we've sort of separated those, right? We have our organization item, we have a user item, but then we have a bunch of ticket items. Then we have another user item. Then we have a bunch more ticket items. So if I want to fetch all my users, I can do that, but I'm also going to get a bunch of extraneous info about all these tickets that are sort of jammed in the middle there that I don't want. And tickets are probably going to way outnumber users because you're going to have way more tickets. You're just going to have a lot of tickets per user. So it's going to mess up your whole results there. So don't do it that way. What we'll do instead, we'll put the tickets somewhere else in our base table. If you want to get a ticket individually, you can do that by its primary key. Here's the ticket ID, things like that. We're also putting these secondary index values. So these are what are called GSI1 values, global secondary index, and this is the first one we're using on this table. And then we're using PK and SK. So just like we did with our primary key, PK, SK, we're going to do with our global secondary index. So we've added these values onto our user and ticket items here. Now, one thing to notice, if you look at that Charlie Munger user and the Charlie Munger tickets, they have the same PK. So they're going to be in the same item collection in that secondary index. We look at our secondary index right here. You can see how Charlie Munger and his tickets are all in the same item collection. We can get that really efficiently. We can handle that get tickets for user access pattern where we also need to fetch that user item. So that's a really efficient one there. So it's basically the same as that composite primary key, but it's using a secondary index to handle this. So this is good when the primary key is already being used for something else, whether it's another composite primary key or whether it's some other thing. You can do this same exact strategy in a secondary index. All right, last strategy, let's do this composite sort key. This one I don't see a whole lot, but you can use it for certain things. So if you have very hierarchical data, this can work for you. Imagine I have Starbucks locations or some kind of restaurant or some kind of locations that are sort of all around the world, right? And maybe I split it up into different countries for my partition key, but then I have this sort key that has a lot of different values encoded into it. And what I can do is if I want to get all the locations in a particular country, I can do that. I can say, hey, give me all the values where partition key equals USA. But then if I say, hey, you know what, even more specifically than that, all the Starbucks locations in the USA that are in New York State, I can do that because I can efficiently search on the beginning of that sort key. So I get just these New York ones. I filtered out the Nebraska ones and all the other ones as well. But maybe you want to get even more specific than that. Say, hey, give me all the locations that are in New York City. And I can do that too. I can say, hey, the sort key starts with NY hash New York City hash. And now I get all those sort of items there. Maybe you want to get even more specific and find it in a specific zip code, right? And you could do that here. And you could say, hey, where the sort key starts with NY hash, New York City hash 10019. It's going to give you only locations in that specific zip code. So the great thing about this is you can search at multiple levels of the hierarchy with a single index, which is really nice. So this is good when you have multiple levels of hierarchy, right? We had country, we had state, we had city, we have zip code, all that sort of thing. And then you can get down to the store ID as well. the big point there is when you're searching at a particular level in the hierarchy, you want all the sub items, right? So here we said, hey, give me everything in New York. It's going to get all those there. We saw before in our last one, where we had organization, users, tickets, things like that. If those are all interspersed there together and you don't want the sub items in there, then you need to split them out into a different item collection. So it doesn't always work, only when you want all the sub items in there. So, all right, cool. Just finished that, and then got a few questions here. Actually, let me finish this up because I'm basically done, and then we'll just do straight questions. So, summary of what we covered here: 3 big parts, like why Dynamo in serverless, right? Apart from the data modeling itself, what are the reasons people are using DynamoDB in serverless applications? And then, once we've hopefully maybe thinking about buying into DynamoDB. Because of that reason, let's look at sort of the data modeling aspects of Dynamo, right? What are the basics of data modeling? What's the terminology, some of the principles there? And then we looked at one-to-many relationships just to bring that home, see a little bit of this denormalization in action, see some of this sort of grouping different types of items in the same item collection, how that all works. So with that, I will take some questions. So Sandesh has one. Let's see. First of all, yeah, there's a survey, so go fill that out, and then if you complete that, you can win a copy of the book. So check that out, and then I'll take some questions here. What are some patterns if access patterns change? For example, we were looking up dealers by name, and now we look up by zip. Yeah, that's a great question. So I'd say one, complexity of using DynamoDB is if your data patterns change, you might have to change the structure of your items a little bit. In a lot of cases, if you're adding new attributes to existing items that you're not querying on, or if you're just adding new items into your table, you don't have to do anything in Dynamo, right? That can just be a code change and just start writing these new things and you'll be good to go. On the other case, if you have existing items in your table that you need to access in new ways that you don't sort of have index for at the beginning, you'll probably need to run some sort of basically like an ELT process where you'll scan all the items in your table for the ones that you need to update and decorate with these new attributes. You do that real quick. And then once that's done, you can create your secondary index and access it by that way. So there's going to be a little bit of a sort of scan update process, but which sounds less fun than sort of just adding an index in a relational database. But I will say, like, you do it once or twice, or you understand it becomes like a very well done formula. You can abstract it in certain ways to say, okay, the only thing I need, like, here's the item I'm looking for, here's the update I do if I find that item. It becomes like pretty easy to do after you've done it once or twice.
Well, Alex, like that isn't really something new. I mean, in a relational model, you would do DB migrations. So this is kind of similar to that. Like you also have to change like some of your data, go through it, or add columns. It's a similar kind of concept, but I think you just need to get your head around.
Yep, that's absolutely true. I mean, I think you're right. Like, some people are. The nice thing about SQL or like a relational database is like adding an index. It feels like I don't have to do anything. Your database is like working hard under the hood to like do all that stuff, and especially like the way it used to be like sort of offline stuff to like add new columns or things like that. There's a lot of work going on, but it feels like less that I'm sort of thinking about. Whereas Dynamo, you have to sort of at least write a little bit of code to do it yourself. But like, yeah, it's absolutely true. Like, migrations are costly no matter what sort of database you're doing, and it just sort of depends on like what kind of cost you're going to take on. Yeah, great point. Andre raised a hand. And Andre, did you have a question that you wanted to do?
Go ahead and
can you guys hear me?
Yep.
Yeah. All right. So my question was that, my expectation was DynamoDB plus serverless. So in my head, I had DynamoDB and Lambda working together. So how would that work together? Because that's the huge expectation that I had, like how you would make DynamoDB work with Lambdas so that you have an entirely serverless SaaS application, so to speak.
Yeah, I mean, you're gonna have to write the function code in your Lambda to actually connect to Dynamo and do those sorts of things. I think the big part there is, if you're using Dynamo, it's going to look similar to if you're using other AWS services, SQS, things like that, in terms of the mechanics there, and also the provisioning mechanics. But, basically what you have is your Lambda code is some stateless code that needs to act on these events that come in, and often is using stateful services outside of it, whether that's SQS or S3 or a database, Dynamo, Mongo, anything else like that. It's sort of like you've got this stateless compute that interacts with stateful services outside of that. Dynamo can be your choice for that stateful service, and you can set it up. And I think a lot of the mechanics of how Dynamo works fit really well into that serverless world in terms of interaction model, provisioning, permissions, billing model, all that sort of stuff. Does that answer your question?
Yep. Yeah, it does. Thank you.
Cool. Yep. All right. Next one. Ishmael, what are the implications of these strategies in terms of performance, storage, and pricing generally? So it depends. I think all of these strategies are going to, the point is you want to have a very consistent read time, no matter as your sort of data scale. So even as your database gets up to terabytes of data, it's still going to be single-digit milliseconds to get a response from Dynamo on these things. So it's not going to be doing expensive operations at read time. In terms of storage and pricing, if you're denormalizing your data and duplicating stuff, that's going to add some storage costs. Absolutely. I think in most cases, I would say that's probably worth paying in order to keep a consistent performance thing. Storage is pretty cheap and not a huge deal. And, it's not a ton of duplication here as well. So that depends. Pricing, it's going to, I think, if you're modeling your data correctly, pricing is very efficient because Dynamo is basically priced on how much data you're reading at a time and how much you're writing. And if you're structuring your data correctly, you're going to be reading a very small subset of items because you're going to be looking exactly for what you need. And you've sort of built your filters into that primary key or into your secondary index. You get just the items you want. You don't get any other ones. And that's a very efficient read, both price-wise and performance-wise. Darius, small atomic calls are cheaper, but if you make a lot of calls, it might be better to use the query API. Absolutely. So this gets into the weeds further than we got, but basically you can get you can read from your table using individual get item requests, or you can use a query API, which uses that item collection concept, right? It says, hey, give me a partition key and I'll give you a range of items back. That query API is going to be more efficient from a cost perspective, just because of, DynamoDB is charging you based on every 4 kilobytes you write. If you're doing these individual get items calls, they're going to look at each of those items individually and round them up to determine your RCUs consumed. Whereas if you're using a query, it's going to get you a batch of items, sum those totals together, and then divide by 4 kilobytes and round up to see how much that is. So a query can be much more efficient than lots of get item requests. Basil, why do DynamoDB people speak so fast? I'm sorry, I can't help it. I'm just copying Rick here. I guess there's just a lot to get out, and we gotta get through it. But yeah, I know you gotta rewatch this again on half speed or something.
I think there's probably some secret society of all of your DynamoDB gurus.
Exactly.
And that's
yeah.
Rule number one. Speak
yeah.
fast
Exactly. I just get so jazzed about it. It's fun to do it, and then I just can't help it. I talk pretty quickly. So, Darius, S3 can also be a part of your serverless strategy to store images, reference the S3 URL to it in DynamoDB. So that's a great point. If you have a big blob of data that you're not going to be sort of querying different attributes within there, you can sort of store that blob in S3. Maybe it's an image, maybe it's a document, something like that, and then just reference it from your DynamoDB item. When you fetch that DynamoDB item, you get the URL and you go fetch that and return that as well. And it can be a lot more efficient in terms of storage costs for you. Sandesh, we learned a lesson that provision tables you will pay for even if they are not used. Absolutely, yeah. And then sort of that's the downside with provision versus on-demand tables. If you have a provision table, you're going to pay for it whether you make full usage of that utilization or if you make none. Just like if you have an EC2 instance that you leave on and don't do any work on, or a database that you leave on and forget to connect to. So if you have that provisioned one, it's going to be regardless of use, you're going to get charged for it. Whereas with that on-demand one, you're only paying for reads and writes you actually do. Really great for if you have a serverless application and every developer has their own test environment somewhere, right? They can spin this up and they're only going to be paying for the reads and writes they do against it, which are going to be super low. They're just testing. It's going to be basically free to have a full copy of that test environment for each developer, which is really great. Again, that on-demand pricing is going to be 7 times more than the provision capacity if you're fully utilizing your provision capacity, which you're probably not. So. Darius, thanks for the kind words about the book. I recommend it as well. Andre, another question. Yeah, if you want
Yeah, I'm back with more questions. Sorry about that. But
not at all.
yeah, so all right. So I'm thinking, we've got AWS Athena, to query all these objects because you mentioned S3 and the whole interaction between DynamoDB and S3. So my question is, which one would I rather store my data in an S3 sort of object and query it with Athena, AWS Athena, or have it in DynamoDB and use DynamoDB as some sort of, key store of sorts. So what would be that? Or can I use both? Or can I use all of them? How would that work? That's my question.
Yep, that's a great question, and it really is hard to like stay on top of the AWS data landscape because there are just like so many different options in there. And they have this whole idea of purpose-built database, which is like depending on your needs, they have a database that fits your needs, but then it's hard to know which one to use. I would separate it in if you've heard of the difference between like OLTP and OLAP type use cases. I think that's a good difference between Dynamo and Athena. So OLTP is like online transaction processing, and that's characterized by like lots of concurrent little reads and writes, right? So if you think about Twitter, when you interact with Twitter, right? If you're fetching a list of tweets, or if you're fetching a specific tweet, or if you're writing a tweet, or if you're looking at a user, things like that, lots of little transactions happening all the time. OLAP is going to be like online analytic processing. That's going to be like big batch, or not batch, but big aggregations. If a PM inside of Twitter is saying, hey, how many tweets did we have this week compared to last week, or what regions are growing the fastest, right? They're going to look over a huge amount of data, but it's also not going to be as time sensitive, right? A PM's like, okay, if I have to wait 30 seconds or 2 minutes for my results, that's okay. Whereas like with OLTP, you want to see your tweets immediately. So that's the big difference between those. I would say Athena is going to be more on that OLAP use case, right? Where you're doing analytic processing. It's looking at a bunch of data, crunching it, doing aggregations, things like that. It's probably not something you're going to want to have user facing unless you're fine like dropping a spinner for them and saying, hey, this is going to take 30 seconds or a minute to get back to you. Whereas Dynamo is going to be for those OLTP use cases, and that's really what it's designed for, getting bunches of little pieces of data all the time. It's not great at aggregations, doesn't even let you do aggregations because aggregations don't scale well. And that's a thing where, MySQL will let you do aggregations. You can do counts, you can do sums and maxes and mins. But the thing is, they're going to perform very differently when you have 1,000 items as when you have, a million or 10 million or 100 million items. Just the performance curve will be very different there. So I'd say that's the big difference. Oh, sorry.
All right, sorry, just to cut you in there. So because OLTP, so how fast is it if I have OLTP when I'm trying to maintain availability? Let's say I've got different DynamoDBs launched in different regions. How reliable is that? Because if you're saying that it's supposed to be real time in quotes, will it work real time? If I want an online transaction processing thing happening in different regions, Europe, US, Africa, how does that work?
Yep. So generally the DynamoDB sort of response time for a request at the sort of server layer is going to be single digit milliseconds, so less than 10 milliseconds to respond. Now, there's a HTTP connection involved there. So if you're making a call from South Africa and going to Northern Virginia, US East 1, that could, you got to make a big hop across an ocean to make that request. So you're going to have some network latency there. So you want to use one that's closest to you to reduce that network latency. The actual like processing latency is going to be single digit milliseconds consistently, which I think is the big benefit of Dynamo. In terms of like multi-region. Oh yeah, go ahead.
Yeah.
No, cool. Thanks.
So if I can just jump in there.
Sure.
As well. So like something that I've seen clients do is to actually add a type on your DynamoDB record, because when you export all of your data from, let's say, DynamoDB to S3 to analyze it with Athena, you can easily find or like group records by type and then do joins more efficiently. And that's just a nice thing that I've seen.
Yep. Absolutely, great point. Yeah, when you're doing those OLAP systems like Athena, right? It's they've got a new feature in Dynamo where you can do an S3 export of your entire table. You export that to S3 and then you query it with Athena. And now you can do aggregations, big joins, anything you want like that. Absolutely.
And actually, Andre, I wrote a blog post like I think last year, and it actually DynamoDB gets faster the more traffic it gets, which is like completely, I don't know, it just blows my mind of like how is this even possible, because that isn't how systems are supposed to work. Yeah,
Yep.
Alex is gonna go back to his picture.
Yeah, I need to go back.
Yeah,
Like
actually
if
to
you
make
look
it go
at
down.
yeah, if you look at it's actually this one right here. Can you see my mouse on the screen? Does it show?
Mm.
It does? Okay.
Yes.
So I talked about how that query comes in, it goes to a request router, and that's going to sort of hash it and look up which partition it belongs to. Now, this request router, there are a bunch of them deployed across an Amazon region, and they have to sort of fetch metadata about these different tables occasionally. Now, the nice thing is if you have a ton of requests, each of those request routers is going to have that metadata cached on that node, and it's not going to have to go out and get it. So that's where that speed up is going to come from, is at that request router layer where they can go and skip that metadata lookup, which is super
Okay, that
cool.
makes
Yeah, I
sense.
love that too. Yeah, I think that's in Rick Houlihan's talk from 2 years ago at reInvent. So the 2019 reInvent, I think he showed a chart where, yeah, they got it actually got faster as the request went up.
Okay, then I think we were at Basil's last question, but I think that was answered now.
Okay, so let's see, Basil's about warning you of costs when you set provisioned RC. Yeah, I don't go in the console much, so I can't comment on that. But yeah. So next one, Alex, what's the most complex data model you implemented in DynamoDB? I mean, I would say if you go look in the book, like I have an example that models GitHub's entire backend in DynamoDB. So you talk about organizations and users and payment methods and repos and issues and pull requests and stars and comments and reactions, all that stuff. Like all that modeled in DynamoDB. That I think the biggest one has like, I think 20 models, 20 different entities in it. I can't remember exactly. But the thing is, like, once you learn the principles, it's like no big deal to add more of them, because it's sort of it just gets fractal pretty easily, and the principles keep working if you keep adding more models. So you can do as big as you want. It will get a little more complex if you need to add new patterns. You just have a little bit more you're sort of stepping on there, but you can do pretty complex data models with these things. All right, Ewan, IoT sensor data, when there's a lot of data being recorded. Yeah, it's tough to know specifics about that thing and sort of what your access patterns are. I think with IoT, you're often talking about two different sets of access patterns. Maybe get a list of readings that you could graph those, but also get like a summary of readings, so I can see what's happened over the last month and how that sort of looks. So it depends on your access patterns a little bit for that, but yeah, usually you'd probably distribute with a partition key that incorporates the dates, so that you don't have super hot partitions. The problem with IoT also is like your hottest partition is always going to be the most recent date, because something that happened a month ago isn't going to change. It's not like the temperature updated a month ago. So there's some things to think about there, and it's hard to do specifics, but yeah, feel free to like reach out if you have any questions as well.